My name's Sarat Babu. I run a design and engineering research company called Bread, which is a group of 6 individuals who work collectively, made up of like artists, designers, engineers, and fabricators and makers. It was basically a kind of response to what we realized was this kind of space in the market. We'd all just graduated out of the industrial design engineering program at the RCA, and what we realized was we'd come through this process of, previously being engineers or previously being designers, and had been kind of exposed to these other types of methodologies and processes, and that there were really new and interesting ways that we could engage with problem solving and kind of like solving design and engineering problems. But the reality was there are very few companies out there that are actually doing that in any kind of manner. There are some really large kind of like, massive engineering firms who can afford to have those kinds of researchers, but there are very few actual like smaller design firms that are kind of really taking that approach on board. So we set up Bread with the aim to try and have something which would allow us to not only kind of like deal with new problems that clients brought to us, but also to develop our own ideas and research forward. 1234 Lab was the first like real time that I kind of engaged in a really collaborative atmosphere. Here you had 4 individuals from really varied backgrounds. I was coming as a material scientist. We had Stefan, who was an electrical engineer through training. We had Herman, who was an Austrian product designer, and Guillaume, who dealt a lot with design and marketing strategy. And you had all of these influences, and the objective for the whole project was to try and develop a range of products which we could kind of like deal with the kind of like experimental side of design, but also could actually, could be sold. And we had to kind of like meet like market requirements to actual, product design. So we started from a really abstract notion of translating sound, and we started to develop a huge range of experiments to kind of like look at how we can physically take sound and manifest it. And probably the most successful product of that was 8 Hertz.
8 Hertz is jewellery formed from phrases of intimate communication. It is said that only 7% of all communication is verbal. Words exchanged between lovers and friends carry significance far beyond their diction. Every exchange is different in intent and perception. Similarly, an exchange of jewellery itself is a communication of unique sentiment. With 8 Hertz, a recording is made of an individual's voice, sampling every nuance, subtlety and accent. This high-definition representation is then translated via a custom algorithm into a 3-dimensional form. The form captures the essence of communication. Each piece is individual and unique to the person who created it. The piece is then realised in precious material in order to capture the moment in a timeless, durable icon representing the unique nature of human interaction. The relation made by the people involved in the communication between the physical object and the communication which inspired it increases its emotional value and personal appeal.
I think the thing with design is that you have to, and this is what is so different from engineering and science, is there is no right answer. You are dealing with the very context of the situation, the very nature of people, and they're very, very complex, and there's nothing ever very specific. When you come up with a solution, you do it in a way to try and take all of those elements, but you bring in your own experience. And I think actually what's really interesting about multidisciplinary work is not the fact that you have people who have specific skills in different areas, it's that because they always view a problem in a completely different manner, right? So one of the great things about Bread is that you may be working on something, and then someone will come over and just literally look over your shoulder and give you an insight which is just impossible for you to do because of the way that your insight is created from your own experiences. So when it comes to collaborating, it's always really interesting to work with someone who is completely new to our kind of like our experience base. So we've had the opportunity to work with with artists, with larger engineering firms, working on architectural projects, but also into biomedical design and serious kind of like prosthetic and implant technologies. And all of those have brought really unique challenges, and it's incredible how even someone like a designer can come up to like what seems to be like a real engineering problem and bring a completely novel viewpoint to it, you know. So I think that's a really engaging part of the work. So, you know, it's not like a standard design consultancy where someone comes to us and they're like, oh, we need you to like design this product for us. It's more that actually we're tending to find that we're engaging with clients who are like, well, we don't know exactly what we want, but you know, we feel like there's something really interesting here, and that's where that's why we want to work with you, and that's where, you know, the really interesting work comes in. I think the one thing that's important to realize is that though this has become a really important subject, collaboration, in the last couple of years, is that this has been something which design and art has been dealing with for a long time, and what really is required is to actually be able to allow people to really accept each other's methodologies and to really like begin to work in a way which is actually quite alien to us right now. I mean, in the way that we create objects, for example, and the way that you would standardly talk about a designer is, the designer is responsible for, you know, the form and the shape, and that may be passed on to an engineer who will then, you know, solve the problems to make it a reality, and boom, you've got your product. But more and more, actually what's required is a serious dialogue. You need a kind of parallel development between those elements. And especially as, you know, we come to areas where actually these disciplines are getting exceptionally close in terms of the understanding of material and architecture and, you know, structure. You suddenly can't work in that fashion anymore. You really need to have this kind of like parallel development. And that really requires a serious level of dialogue between all of the elements. And I think that's what we're trying to capture with Bread and the work we do. It's difficult because you're challenging the way that commercial companies work. A lot of companies, for example, are you know, they're engineering companies, and they're very comfortable with what they do. They know exactly what they can do, and then how to do it, and how they finish. What we're trying to say is that, okay, but what if we actually bring design into that process? The possible rewards are great, because you can come up with things that just one methodology alone would never allow you to do. But at the same time, it brings you know, a certain level of risk. So it has its challenges, but, you know, again, the possible rewards are pretty great. It's only been a year, but like a year and a bit actually, but we've had a lot of, like, a huge variety of different projects, and probably one of the most interesting has been engaging with Sony Music. And we've been doing quite a bit of work actually for quite a bizarre client, where they're attempting to kind of, we've been working with their viral marketing department to actually build installations and spaces around that. So the kind of characteristics of the actual projects themselves are really varied. They're kind of like, we've got 3 months, we've got X amount of budget, we want to build a robot which can receive tweets and write onto a mirror, which self-cleans itself, and you need to do that within like 2 months, like, time span. And it takes a, you know, it takes a huge array of people to actually, like, you know, deal with that kind of problem. So the way that we work in Bread is that usually we split ourselves up to kind of deal with the actual realities of the problem. So for that project, for example, I was working on it in terms of the actual some of the design and fabrication, but the main lead project was a guy called Matt, who actually, you know, if you look at his previous experience, he spent the last, you know, 10 odd years fabricating Porsches in Colorado, right? And it's just that intake and his understanding around a workshop, which is not from an engineer's point of view, but an actual understanding of how you actually build things, which is quite a different thing, which is really, you know, relevant to that kind of project. There's a project we're working on right now, which is, because we like to do our own internal work as well, it's also a big focus. A lot of us have different research elements. So I have a lot of like material research, which is currently happening. Matt actually also runs a company called Bear Conductive, and through the RCA program they developed a skin-safe conductive ink, which has had a lot of press recently, which has a lot of really interesting applications, which they're looking into the medical field, but also in terms of interaction, etc. One project we're really working on is looking at kind of like a bicycle helmet, and it's a very simple, what seems to be quite a simple problem, and there's a lot of debate about like how these kind of like helmets actually work, but it kind of really incorporates a multitude of all of our researches. So we've been doing a lot of work recently, for example, with the Connect, and we've been doing that because what we want to do is build a very cheap 3D body scanner, right, which you can utilize you can actually get this technology for exceptionally cheap off the shelf. And if we can adapt that, can we actually be able to start using that in product design? So since we've been doing stuff around the head, what we've actually been doing is using the Kinect to basically actually, as a 3D scanner, to scan the head in order to allow you to have like 3D data which you can then use to kind of custom build your helmets. At the same time, we're using a new type of material technology in functionally graded materials in order to actually design the helmet so it absorbs a higher range of stresses, and actually to use new manufacturing processes like rapid prototyping to actually not just prototype but actually manufacture the helmet. So it's dealing with everything down from actually how you start to begin to conceive of the design and the sketching of it, all the way through to the actual production and the testing of it. And it's being able to engage with a project like that in the commercial world in all of the elements, which is really, really exciting. So I mean, those are the kinds of things that I think are really, really exciting for us.